So these rules apply when we're differentiating a product of two functions or a quotient of two functions. So what we'll do, we'll concentrate on the product rule first. So we saw last time that the chain rule applied to a function wrapped around another function. So for example, 2x plus 3 is a function, and if I wrap it in another function, power 4, or let's say sine x plus cos x is a function, and if I wrap it in another function, say ln, that's when the chain rule would apply. But actually, we saw that the chain rule didn't apply last week when it was the product of two functions. For example, x times ln x. The chain rule didn't apply there, and there's actually a different rule for something like that. So I'll start by just telling you what the product rule is. So the product rule, this is a key point to write down. So when we're differentiating the product of two functions, so d dx, let's call the first function u and the second one v. So it's v du by dx plus u dv by dx. And there is a proof of that, which I will put online. But it's quite a long proof, so I'm not going to do it now. I'm just interested now in showing you how to do this. As I say, if you have enough interest to look at the proof, please do. So, e.g., find, and let's use the example I gave before, d dx of x log x. So differentiate that. So the first thing we've got to do, looking at the product rule here, we've got a product of two functions, u and v. So let's write, let u equal the first thing in the product. So let u equal x. So that means that du by dx is 1. Secondly, let v equal log x, the second thing in the product, which means that dv by dx, and the differential of log x we found out last week was 1 over x. So now we're ready to put it into the product rule. Therefore, the differential of x log x equals v du by dx, so log x times 1 plus u dv by dx, x times 1 over x equals log x plus 1. And there's the differential of x log x, becomes log x plus 1. So v du by dx plus u dv by dx. Let's do another. E.g., find the differential of x to the 4 e to the 2x plus 1. Have a go doing that one yourself. Follow the same style of working that I did above. Now this one also incorporates the chain rule as well. So you are going to need to use the chain rule for this, as you probably will in most exam questions. So I'll give you a moment to get through that. Another 30 seconds or so, and I'll start. So u equals x to the 4. which implies that du by dx equals 4x cubed. V equals e to the 2x plus 1, which means that dv by dx equals, well, it's itself, using the chain rule, e to the power of something differentiates to exactly the same thing, times the differential of what's in the bracket. Now, there's not a bracket drawn, but if there were, it would be there, around the power. A function, 2x plus 1, wrapped in another function, which is in this case is e. So times the differential of the bracket, of the innermost part, times 2. So now, that means the differential of x to the 4 e to the 2x plus 1 equals vu dash. So I'll start it down here to give myself enough room. vu dash, so e to the 2x plus 1 times 4x cubed plus uv dash, so plus x to the 4 times, and I say v dash, obviously I mean dv by dx, that's just alternative notation, 2e to the 2x plus 1. Okay, then finally, let's make it prettier, because currently we don't have numbers at the front, which is the convention in algebra, so present it like a proper final answer. So 4x cubed e to the 2x plus 1 plus 2, and I'll put the x to the 4 at the front like I did on the previous term, so 2x to the 4 e to the 2x plus 1. Now, we don't need to factorize this, because we're not being asked to solve anything. We're not being asked to, for example, find any stationary points, so we won't. But we'll do a few examples later where the expectation is that we should factorize it. So, got an example for you to do here. A couple of examples. Find the value of f dash x, i.e. the gradient, at the value of x indicated in each case. Have a go at that first one. Give you about 30 seconds, then I'll start. So find the gradient at each of those x values. So I'll quietly get on with it. So once we've found the differential, find the gradient, and it's asking us to find the gradient at 0. So f dash 0 equals 4e to the 3 lots of 0 plus 12 lots of 0 e to the 0. Obviously that disappears, and e to the 0 is 1, so the gradient is 4. That's part A. Try part B. So be careful when differentiating this one. You can see there's a function wrapped in another function. We've wrapped a cube bracket around x squared plus 2. So bracket cubed differentiates to 3 bracket squared. Take a look in the bracket and see what's in there. Times by its differential equals 6x x squared plus 2 squared. So now using the product rule, v du by dx. So v du by dx times those two together plus u dv by dx times those two together. I get 12x squared plus 12x squared, x squared plus 2 squared. V du by dx plus u dv by dx. So now finding the gradient at -1. Subbing the values in, 2 lots of -1 squared plus 2 cubed plus 12 lots of -1 squared, -1 squared plus 2 squared. So putting that in the calculator exactly as it appears there. So 2 lots -1 squared plus 2 close brackets cubed plus 12 lots of -1 squared -1 in brackets squared plus 2 squared, which gives me 162. So I'm a little bit suspicious about that answer. So what I'm going to do is I'm going to check it using the differentiation function on the calculator. I'm going to take the original expression and differentiate it. So the differentiation button's here above the integration button, shift, then that, and that'll allow us to differentiate a function. So 2, and the x is in the top right hand corner, 2x x squared plus 2 cubed at x equals -1. Let's see if that's 162. Yeah, it is. Okay. But I was right to be suspicious of a quite high number. So it's better to check. While we're at, let's check this answer here as well. So again, d dx of 4x e to the power of 3x at x equals 0. Hopefully the answer is 4. It is. So we know we're right. So let's move on to a stationary point question now. I mentioned before that they can be more difficult. So we'll do a few of these. They really are worth having a look at. So let's try a few. So find the coordinates of any stationary points on each curve. So the first one we're going to look at is x e to the 2x. So I'll just paste it on the screen. There we go. So find the stationary points of that. Now this will involve factorizing. Find the gradient, set the gradient equal to 0. That's what a stationary point is. Something with gradient 0. And then find the corresponding y-coordinate. So take a moment, differentiate using the product rule, set it equal to 0 and solve it. Right, okay. So we've got u equals x, du by dx equals 1. We've got v equals e to the 2x, and dv by dx equals 2 e to the 2x. Which means that dy by dx equals v u dash plus uv dash which is equal to 0. And it's really important that you write equals 0. That's worth a mark according to the mark scheme in an exam. So now just for you to solve that, the best thing you can do to solve something like that is factorize. So have a go at factorizing that. So I notice they've both got a factor of e to the 2x in common. That's 1 plus 2x equals 0. And we can deduce two things from that. So we've got the product of two things equaling 0. Either the first thing equals 0, or the second thing equals 0. Now, from your knowledge of exponentials, you should know that this isn't a solution. E to the 2x can never equal 0. If we try and ln both sides to get that 2x out the power, we get ln of 0, which doesn't work. So I'm going to discard that. But as is the case with the linear spec maths, whenever you discard an answer, you should say why. So e to the 2x is always greater than 0. That's why I'm discarding that. So that gives me x equals minus 1/2. So I'm not done yet because it asks for the coordinates. I've only found the x coordinate. I need to find the y coordinate now, so I need to sub it back into the original equation. So let x equal minus 1/2, which means that y equals minus 1/2 e to the 2 lots of minus 1/2 x. Sorry, I've subbed, not x, I've subbed in the minus 1/2 instead of x, equals minus 1/2 e to the power of minus 1. And there's our y coordinate. So let's conclude. Therefore, stationary point at minus 1/2 and minus 1/2 e to the minus 1 give exact coordinates. So let's do another, and this one's going to be a little bit more complicated. So let's find the stationary points of this particular one when it appears. Oh, there it is. So product rule again. Find the stationary points. But this one, as I say, is a little bit more difficult. I'll give you a moment to get started on that, then I'll take over. So there we have it, and there's our equation to solve. So we've got 2x minus 3 to the power of 4 plus 8x squared 2x minus 3 cubed being equal to 0. So again, factorizing is the key. When we've got something equal to 0, if we factorize it, we know both factors, or however many factors there are, it might be more than 2 factors. When on a fully factorized expression equal to 0, each of the factors can equal 0 to make that equation work. So each of these have a factor in common. We've got the number 2. I can see they've got 1x in common as well. And I can see they've got 3 of these 2x minus 3 brackets in common. So I've taken out the biggest power that I possibly can of each of those brackets, of each of those factors. So now, because I'm going to draw, there's going to be lots of brackets that are right here. I'm going to put a square bracket so as not to get my brackets mixed up. So the first factor, so let's compare. Let's think, what do we do to get from here up to here? So I can see I've got a 2x in front, so I don't need to do anything with that. And I can see I've got some 2x minus 3s, but this has got one more 2x minus 3 bracket than that. So to get to that one, what I'm going to have to do is times by 2x minus 3. Try and keep the colour the same. 2x minus 3. So now if I times that there by that, I get 2x times 2x minus 3 to the power of 4. But one thing to note, these brackets aren't necessary. I'm still timesing this by this with or without the brackets. So I'm not going to write the brackets in. Then there's a plus sign. Now I can see that here I need to get from 2x to 8x squared, so I need to times by 4 and x to get 8x squared. And I've already got the correct number of 2x minus 3 brackets. I've got 3 and I need 3. So when I times that by that, I indeed do get 8x squared, 2x minus 3 cubed. So this is just a bit more advanced factorizing, which is equal to, that just becomes 2x minus 3 cubed, and we've got 6x minus 3. And we know that that's equal to 0. So we fully factorized it now, and we've got 3 factors. So that tells us either x equals 0, or x equals 3 over 2, or x equals 1/2. 6x equaling 3 means x equals 1/2. So I've got 3 stationary points now that I need to find the y values of. So I'll leave the original equation on there. So x equals 0. Well, trivially, if we sub 0 in, y equals 0. 3 over 2. Let's put that in. So y equals 3 over 2 squared. 2 lots. 3 over 2 minus 3 to the power of 4. Type that in the calculator. Three over 2 squared. 2 lots. 3 over 2 minus 3 to the power of 4, which gives me 0. And then x equaling 1/2. Well, let's go back and just modify this. Change the 3 over 2 to 1/2. which gives us y equals 4. Y equals, so let's put the working in full. 1/2 squared, 2 lots of 1/2 minus 3, the power of 4, which we found out indeed was 4. There it is there. Okay, so conclude now. Therefore, stationary points at the origin, 3/2, 0, and 1/2, 4. So last one of these stationary points questions we're going to do, but it's an interesting one, another tough one to factorize. Try and find the stationary points of that one there. Have a go. And with this one, v equals x plus 12 to the half, so dv by dx equals 1/2, x plus 12 to minus 1/2. Always remember to times by the differential of the bracket. The reason I haven't written times 1 here, obviously because that's a trivial sum to do, but I'm always thinking multiply by the differential of the bracket, so I am timesing that by 1 after I've done that. It's a good way of thinking to get into. So dy by dx equals v du by dx plus u dv by dx. Which we know is equal to 0. Now factorizing this is the hard part. So they've got the x plus 12 in common. I'm just going to scroll back up a second to what we did on this one. So here, on this one, so it's a bit of confusing terminology because before I said I take the number, the biggest power that we possibly can, that they have in common, which was 3. But actually, that statement is a little bit flawed, and we all use it, and it's a correct statement, but it's a little bit confusing when we do ones like this, because the biggest number of things that they have in common is actually the smallest number. So you might think I'm stating the obvious here, but it really helps when we come to trying to factorize that. So 2x minus 3, we've got 4 and 3 as the powers. We take the smallest number. The smallest number is the biggest number of brackets they have in common. And that's what we're going to do here. We can see that we've got this x plus 12 in common. So we're going to take the smallest number that they have in common, which is x plus 12 to the minus a half. So that's a common factor. I've got x plus 12 to the minus 1/2. And what do we times this by to get from there to there? We need to raise the power of this by 1 to get from minus a half to a half. So we're timesing by x plus 12 to the power of 1. X plus 12 to the power of 1. But again, something to the power of 1, we just don't need these brackets. X plus 12 to the power of 1 is x plus 12. Plus. And what do we do to get from there to there? We just times by half x. Equals 0. Which means that x plus 12 to the minus 1/2 times, so that's 3 over 2x plus 12 equals 0. Now I'm about to make an incorrect statement here. So that means either x plus 12 equals 0 or 3 over 2x plus 12 equals 0. Now that statement is incorrect because actually this bracket can't equal 0. It's a negative power. It's a reciprocal. If we let this equal 0, that's like the denominator equaling 0. Because it's a negative power, it's on the bottom of the fraction. We can never have divided by 0. So it's not just that we'd write that and cross it out. We should know just never to write that in the first place. So the only solution is when 3x plus 12 equals 0. So that means that 3 over 2x equals minus 12. Times by 2, divide by 3. Which means that x equals minus 8. And now we need the y values, which means that y equals minus 8 plus 12. So minus 8 to the power of a half, i.e. square rooted. So root 4 is 2 equals minus 16. Therefore, stationary point at, and it was minus 8, minus 16 is our answer. So that's basically the product rule. Not much more to that. A few worksheets that you can be getting on with after the lesson, and I'd recommend you do that. I would recommend you become well practiced at this. But now I want to move on to the quotient rule. So the quotient rule applies to fractions when we're asked to differentiate fractions. So if we're asked to differentiate this, and a lot of the exam boards give you this in the formula sheet, that's the case there. d dx of a quotient u over v equals v du by dx minus u dv by dx over v squared. So when you've got a fraction, u on top, v on the bottom, this is how you differentiate it. As I said, that there is the key point. So let's have a look at an example. So I'll take one straight from a worksheet. So it is just, I'm not going to spend too long on explaining the workings of this because I think it's just something you can do. So we'll do a couple of examples. As I say, it is just plugging things into a formula. The trick is knowing when to use it, i.e. when you have got a quotient. So have a go at each of those. U on the top, V on the bottom, and lay it out as you would have done for the product rule. u equals, therefore du by dx equals, v equals, therefore dv by dx equals. I'll give you a moment to get started, then I'll take over. So v is the thing on the bottom of the fraction, so v is x plus 4. A common error will be to write x plus 4 to the minus 1. That's not the case at all. The thing on the bottom of the fraction v is x plus 4, not x plus 4 to the minus 1. So that's just to simplify as well. So gather up all the like terms. So the numerator becomes 2x squared plus 8x minus x squared over x plus 4 squared. And we shouldn't expand the bracket on the bottom. Factorized is simpler. So actually by multiplying out the x plus 4 squared, you'd be unsimplifying it and probably lose marks. Factorized is always better. Equals, so we've got x squared plus 8x on the top, x plus 4 squared. And as I say, factorized is simpler. We probably wouldn't get any extra marks for factorizing the top here. But as I say, we probably would lose marks for unsimplifying. So it's up for debate whether it's whether we should make the active effort to factorize. It's just the way mark schemes work. But I'm going to anyway, just to be safe. X plus 8 over x plus 4 squared. Try B. Right, so u equals x minus 4 to the power of a half, which means that du by dx equals a half of that to the power of minus a half times the differential of the bracket, which is just 1, so I'm not going to write that. And v, put the implication sign there as well, v equals the thing on the bottom, which is 2x squared, which means that dv by dx equals 4x. So dy by dx equals v times the differential of u. So 2x squared times a half, probably easier just to write the times sign, times a half, x minus 4 to the minus a half, minus u times dv by dx, 4x, x minus 4 to the power of half, all over v squared. So 2x squared, all squared. And let's simplify that now. So that's equal to, well, 2 times a half is 1. So that just becomes x squared, x minus 4 to the minus 1 half, minus 4x, x minus 4 to the power of half, all divided by v squared. And in this case, I think multiplying out this bracket does make it simpler, as would a mark scheme. Having a bracket, having a single term raised to a power, and not simplifying it, that would be bad form. Because it's quite trivial to say that that's 4x to the 4 on the bottom. And I hope you agree that that does look simpler. So this wasn't proper factorization. This was sort of half factorization, bit lazy to leave that unsimplified, to leave that unmultiplied out. Okay, and this is one of the ones just like before. So we're going to factorize this. And again, we probably wouldn't need to. It said simplify. This is probably as simple as it's going to get. But let's factorize anyway, because we might be asked in an exam question to find the stationary points for a function like this. So they've got an x in common, and they've got one of these x minus 4 brackets in common. And remember, we'll take the smallest power out like that. Okay, so we times the first thing by x to get the first term. Then there's a take sign, times by 4. But also, we need to raise the power by 1. We need to go from x minus 4 to the minus a half, all the way up to x minus 4 to the power of a half. Raise the power by 1, so times by a power 1 of that bracket. And we don't need to write 1. Over v squared. Equals, so x minus 4 to the minus 1 half, another bracket. So x take 4x is minus 3x, and minus 4 times minus 4 is plus 16. All over 4x to the 4. There it is, fully factorized. So that's basically the quotient rule. So let's now try one more example. So I'll take this from an exam paper. So final example before we finish. There it is there. So given that y equals that there, show that dy by dx is that. Then find the exact value of the gradient at the point where it crosses the x-axis. Take a moment, have a go. I'll take over in just a second. So this one, u is the thing on the top, so it's going to be the quotient rule because it's a fraction. So u is 4 log of x minus 3, which means that du by dx equals, so 4 log x differentiates to 4 lots of 1 over x, so 4 over x, and the minus 3 differentiates to 0. V equals 4 log x plus 3, which means that dv by dx again equals 4 over x. So dy by dx is v du by dx. I'll start it down here, so there's plenty of room. Dy by dx equals v du by dx minus u dv by dx all over v squared. And here I'm very, very uncomfortable looking at fractions over fractions. It's not good. So 4 over x on a numerator isn't a good thing. So what I'm going to do, I'm going to times by 1 so as not to change the value of this fraction. But I'm going to times by 1 in a clever way so as to undo that divide by x that's on the top. So timesing by 1, but the effect of timesing all of the top by x is that these divide by x's disappear. So equals 4 log x plus 3 minus 4 log x, put the bracket in the wrong place there, 4 log x plus 3, like that, minus 4 log x minus 3. And don't forget each of those. So I've undone the divide by x, but the 4 is still there. So best not forget that 4. 4 lots of that. Take away 4 lots of that. And on the bottom now, remember to times the bottom by x as well. So x times 4 log x plus 3 squared. So we're a bit closer now. We can see that the denominator matches what we need it to. So now the top becomes 16 log x plus 12. Then take 16 log x and minus 4 times minus 3 is plus 12. All over v squared. So all over, oh well, now the x times v squared. 4 log x plus 3 squared, almost there. 16 log x, take 16 log x. And let's conclude. Equals 24 over x 4 log x plus 3 squared. And there's the full answer there. And just sticking as required there. Now part 2, find the exact value of the gradient of the curve y equals that there at the point at which it crosses the x-axis. So that's telling us that y equals 0. When it crosses the x-axis, y equals 0. So we need to find a corresponding x-coordinate to sub into our gradient formula. So solve that. Now to solve that, it's the numerator that has to equal 0. For a fraction to equal 0, it has to be the top that equals 0. Remember, we can't divide by 0. So we've got 4 log x minus 3 equals 0. Once we've got that, sub it into our gradient formula. So I'll give you a moment to work on that. Take over in a couple of minutes. Okay. So 4 log x minus 3 equals 0. What I'll bring the question down just so I can see it still. So there it is there. So part 2, I've got that the numerator, 4 log of x minus 3 equals 0. Which means that 4 log of x equals 3. Which means that log of x equals 3/4. And if I e both sides, I get x equals e to the power of 3/4. So now I've got my x value to sub into the gradient formula. Therefore, dy by dx equals 24 over e to the 3/4 for log of e to the 3/4 plus 3 squared equals 24 over e to the 3/4, and log of e to the 3/4 is just 3/4. So 4 times 3/4 is 3 plus 3 squared equals 24 over 6 squared over 36 e to the 3/4. So that's 2 over 3 e to the 3/4, which is our final answer. Or alternatively, don't have to put it like this, could have 2/3 e to the minus 3/4, which is an equivalent answer as well. That's that, done. So that there is the product and quotient rule for you. So the worksheets that I've put online, have a go at those. Do as many of them as you can. When you feel you're ready, have a look at my exam questions that I've made and I've put on the website. So there's There are much harder questions that I've made on this as well. So I've done a section of introductory questions, a sheet of introductory questions, and a sheet of more difficult questions for when you feel you're ready. So have a go at that.